Hello there, welcome back, welcome to my YouTube channel. So today I'm going to show you how to download stage 4 precipitation data, and I'll also show you how to create time series from this precipitation, but this time it is a little bit different than previously what we already seen, right? The previous NetCDF file was only one file and it has like time chunk, but this case we have only one file for each time step. Then we have to do the processing in a different way. So I'm going to show you how to download that data first, because the benefit of using this stage 4 precipitation from this website that I'm going to show you right now is because this data is already in NetCDF format, but the previous data set either in MRMS or stage 3 or stage 2, these all are basically in GRIB format, because that GRIB 2 or GRIB 1 gridded binary, that is pretty complicated, but yeah, sometimes it is useful as well to store a lot of information into a single file and within a very small memory. So that is the benefit of using a GRIB file. But this website, you also have this stage 4 precipitation data in GRIB format. If you are interested in that one, you can do that. But here I'm going to show you the processed data. It is already processed and converted to NetCDF, and the file size is pretty small, and you can use that one as well. So I'm gonna download this from this AORC NWS. If you just source this one, you'll see the analysis of record for calibration. So that is the website. If you search, and you'll be here, and then if you go to this one, index or AORC historic, then they will just direct you there. And you have a lot of options here, because these are from basically that RFC, River Forecasting Center, and there, because I'm going to download this data for the WZRFC, okay, West Gulf River Forecasting System or River Forecasting Center here, okay, because I'm going to download this one for Texas, this area. I'll show you the aerial extent. If I click on there, and it is going to show you even temperature. If you want to even download the temperature data, you can even do that, because see, we have this data from 1979, right, from 2nd of February or from February. But if you want to download only the precipitation, these are TMPR, temperature data. If you want to download precipitation or rainfall, that's that. You have to go there, right, at the very bottom. Click there, and you can see we also have the same data from 1979, right, February, and then we have up to today. Here we can see this data. But if you want to, since I'm going to even extract the time series, I need to show you the plot so that you can understand that, okay, we are extracting the time series, or we are generating the time series accurately. So that in order to do that, I can even download this data for a shorter period of time. For example, I'm going to download this for Harvey. Then you can see we'll have a very high peak, and I don't need to download all this data for entire year. And you can do that because we have this data, the monthly file in a single month. These data are basically hourly data, and in a single zip file you will see we have the hourly data, and I'll unzip that one and you'll see that. So I'm going to download for Harvey 2017, and here from, because Harvey basically hit the coast of Texas and Louisiana like at the end of August. So I'm going to download this data for August and September, okay, these two files. If I click there, then file size is pretty convenient. You can see that it's pretty convenient. See, file size is 16.8 megabyte, and it's covering the entire thing, and I already have downloaded this one there. So if you click there, you'll have this, and if you click there for September, and you're done. It is also pretty convenient. So once you have this data, downloaded data there, right here, so what you have to do, you have to unzip this one, and if you already have that software installed, just extract. And before extracting, because it will make a lot of files here, I'm gonna copy, and I'm gonna create a new folder, means stage 4, okay, stage 4 precipitation, stage 4 precipitation, and I'm putting it there. this, okay? And I'm just unzipping here, and let's see what we have. And then I'll check the aerial extent, and I'll show that before extracting and processing. I have this one, and then, so these are the demerit of using that Windows. But if you use Linux machine, it will be very convenient to use that one. So I'm extracting manually because these files are not that big. That's why otherwise I use Linux machine. I'm deleting this one. I don't need this. And what I have to do, see inside this file, I have a lot of hourly files for entire month, right? For 1 month, I have 744. So what I'm going to do, I'm going to even select and then Control X, and I'm putting it there all together, okay? Then I'll delete that one. So for September, I'm going to do the same thing, Control A and Control X, and I'm putting there. So I have this data in a single folder, right? And then I'm going to delete that empty, this one. So we're done. See, you can check the name of the file, right? These are the AORC, that data. And then WGRFC, and you can see the date. This is very important part for our case to generate time series. 2017, August, right? 1st of August and 00 hour. So these are the year, month, day, and the hour. And we have this data all the way to the September 30, right? And 23rd hour. So we have this data. Each data will have several variables, and let's see what variables we have. Let me just plot it, and I'm going to show you the aerial extent of each of this file, and you'll see. And because without understanding the variables and aerial extent, we can't do that, right? Here we have, I'm just opening one file, and here the APCP surface. Okay, this is the variable name, and you can read that. Short APCP surface, we have the time, one time. It is basically three-dimensional data. The first step is the time, and then we have the latitude. We have 450 latitude values. Basically, these are the columns, and we have the rows 495. And see the unit, you can see kg per meter square. This is basically the millimeter. If you have a kg within 1 meter square area, basically it represents millimeter, right? So if I want to plot it, and you can see the aerial extent, here it is. That is the area we downloaded here, see? There. And if I even try to make it bigger, so for this case, it is this. And if your area is different, you can select, if you know your river forecasting zone, then you can even go for that one. See, basically this is covering the Texas, coast of Texas, okay? And Louisiana as well, here a part of this. Okay, so we have this aerial extent, and if you have your point anywhere within this region, right, within this region, and we can see, we can find one location, right, we can see, and we can even, if we have multiple location, we can even do that. But I can tell you some station location here, and I'm going to show you this one. This is only for demonstration, nothing else. The levels, the map, and here I'm going to give you that 0.5 degree, and then I'll show you that every grid line, and it should be 10. See, it is pretty active, right? Okay, so I have to find out this grid or the coordinate. If you know the coordinate of your study area, if your study area, right, is within this limit, you can find some stations that may be observation station, and if you want to even compare with your simulation or your observation, if you want to validate your model, or if you want to even create the input file for your hydrologic model, you can even process this precipitation data, okay? So how can you do that? So arbitrarily, what I'm going to do here, I'm going to even, okay, let me just try to find a good point or two so that we can understand. See, this is basically 98, okay? 98, and if I select this point, so I'm going to write first one, longitude, okay? Longitude, First one is minus 98 since it is west, and if it is 98 and corresponding latitude is 26 north, this point, okay, 26, 98, 26, and I'm going to select few points, few of them, and then if I select this one, it is 98, still 98, and for this case it is 28, and if I have another point there, we can even select 98, 30, okay, 98 and 30, and if I have this point, it is 98, 98 and 32, and this is how I can go up and all the way to this one. So this will be point. I'll show you how to create this point, and if you have one point there, because we can see, right, we have a lot of information there as well, but how we hit this area, so we can even select this point as well. Okay, so what will be the value of this one? It is 96, okay, 96 and 30, and if you want to click this one, 97, another point will be 97, and it should be 29. Okay, these are the session. Okay, we can even select more. So how can I do that? So let's try. I'm going to open a Jupyter notebook because I have similar code from my previous tutorial. You can watch that one, and then if it is not a problem related to memory, because this time these values are not that big, we can do that. So in order to even see the variables, right, these are the steps I follow usually. You have to import OS and system if you need to even reproject, because you have to check the projection system. If your model is in different projection system and if your precipitation is in different one, so you have to, right, convert it to the same projection system. So, and the main topic here, I'm gonna use that NetCDF4 module, right, to read any NetCDF data, because these are the NetCDF4. So I'm gonna use NetCDF4 module, and I'll even process some data using NumPy array. That's why I'm importing NumPy as NP, and definitely I'll deal with date time and data frame as well. So that's why I'm gonna import this pandas as PD, and definitely I'll deal with date time and time data. I'm importing this one, and I'm just suppressing the warning if I have any. So these are the thing. First step, I'm just creating a new, okay, creating a new, copying and making it fresh here, because I have several things there, and I'm just starting from there as header, and this should be time series, okay, time series from stage 4 rainfall, okay, rainfall data. This is the header, and then I'm gonna paste it there. I have this header there. I'm just writing the code, and when I write the code for the first time, I use Jupyter Notebook, and then I just use my Linux machine, or you can use even Spider, whatever you want. So now I have this one. So, and then I need to even show one data, then I'll loop through all of this, right? So, okay, because I have this mouse that is pretty fast. Okay, so we are here, right? We are here. I'm going to show you in a bigger font. So let me just show the location where I have this data. It should be there, and I'm going to select only one file, okay? Only one file to see the variables. If you want to copy the path, go to properties and security and copy it from there, and you will have that. So I'm going to even put it there. Here you can see I have this, and I'm just putting R as reading mode, right? I have to use / instead of backward. Here you can see that path is pretty long. Okay, not a problem. We have this data, and we'll loop through all of this. And if it is okay, so now what I have to do, I have to see, right? I have to see the variables, right? How can I do that? Because it is an object, data object, and then variables dot keys. And if you do it this way, it will show the variables we have: APCP surface and latitude, longitude, and now we can even see what are our dimension of this data, right? Variables, and in those variables, if you put that FECP, you can see the information of this one, okay? And what is the unit and everything. You can see the properties here. You can see the missing values, and you have the current chef. The first has to be time, right? It is there. The first one is time, and then latitude and longitude. If you pass the index of time and the index of the latitude for your specific point and longitude, then definitely it will give you the value. And if you want to even import, okay, if you want to even import or save or show all these values of precipitation, I'm going to show only for few of them. And if you want to show this way, it will give you everything. Okay, let me just run it. See, it is going to give you this, the first rows and columns has 0 value, so that's why it is there. Okay, I'll store this one, not a problem. I'm just checking the variables I have this way. And if I want to check the unit and variable for other, like latitude, longitude, and time, for example, latitude. Okay, let's see what we have. It is similar. The name should be latitude, and it is basically degree north. It is already in degree, right? So we don't have to be worried about it. Okay, so we are done with this one. And time, for time, let's see if I want to even check time. What is the unit of the reference time? That is very important. And here we can see the time, seconds since 1930, and this is the time, 1st of January of 1970. Okay, 1970. And the time we have, it should be in second. And if I want to print the values of time, you'll be amazed that it is pretty big number. Okay, and I'm not going to show all this time. I'm going to show only the first 10 values of time because it has only one shape. So these are the values of time. See, can you see that? It's a pretty big number. These values, basically it is in second, and this second, if you calculate that manually from 1st of January of 1970, you will find this number of second. So we'll use this second to calculate our starting date of our data, because our data is starting from, we know that, right? We can do it in 2 different ways because we know this data, right? You can see that the date is there. We can even calculate our date time object using this file name because it is already written there. We don't need to even start the same thing we did for ERA5. If you didn't watch that video, you can go back to my previous video, the last video I uploaded. You can check that how did I generate that date time object from this reference date. But for this case, since we already have this information there, right, in the file's name, so we can select this part and then we can generate our date time. So that would be easier way, right? Whatever the sequence of the file, whenever it will read this file, whenever it will loop through this file, it will get the date time and it will create date time object, and then we'll make time series out of this one. So okay, let's go for that. So I think we are already done, right? We're already done with exploring our variables. We are pretty good. So now I have to specify, so I have a similar code there. So what I have to do, I have to, okay, so after doing that, let me create the input or output directory. These are the directory where I have to do that. And here it is. Okay, so I'm specifying my output directory of my time series. It should be within that. Okay, it is going to be within our stage 4 precipitation. Okay, it will generate one new folder by the name of precipitation or rainfall. Okay, rainfall TS, rainfall time series. And it will check if this directory exists. Currently, there is no name by this one, rainfall TS, so it will create one. Okay, and then I'm going to read the file name. Okay, the station name basically, because the location I just mentioned you here from this map, because I don't know the location, I'm just showing you if we have any location. I just calculated the location, right? I'm going to give the name as station 1, 2, 3. I'm going to prepare a similar file because it should be pretty easy. I'm going to copy the file and change the location name. It should be within my ERA5 there. I'm going to copy this file and I'm going to put it there. Stage 4, it should be within my download right there. Here, right? See? I can put it there or I can put it anywhere. I can put it anywhere, it doesn't matter. Okay, even I can use the same value and I can put it there as well. Okay, I'm putting it there, and I'm gonna rename this file as station. Okay, station means rainfall. Okay, station rainfall. And what will be the location of our station? Because I have many stations here, I don't want to waste time on that. So for example, I'm gonna give the name as this one, and first one will be the serial, and I don't need this, all of this, okay, because I have to provide the location of all of this one. Okay, I'm gonna just delete all of this, and I'm gonna create the time series for 10 locations. So what I have, longitude, right? Previously I mentioned that one, it should be -80, and the corresponding value was 26, right? The name should be anything. If you know the station name, you can put it there. And then the next one, if you want to even generate the time series for the same longitude value, 80, and then that should be, it will increase, right? 26.1, for example, this one, I'm just increasing number, or 26.25, and this should be minus 80, and then that should be 26.5, and here if it is a -80, I'm just arbitrarily giving so that it is within our study area or the data we have, right? So that should be 26.75, and -80, that should be 27. Okay, and then I'm going to change the location from this one to that one. It should be -96, and that should be 30, and if it is -96, that should be 30. Okay, 30.5. I'm just giving the name, and then that should be minus again 96, and that should be 31, and then I'm gonna put -97, and that should be 29, and -97, that should be 29.5, and that should be -97, and this should be 29.75. Okay, this is the location. I'm just saving this one. I'm gonna loop through all these stations and generate the time series based on the name of the station, right? Name of the station .csv. Okay, so I just saved it, and I'm gonna copy the location as well here, right? This is the station I have, rainfall, properties, and then security, and copy the name and the path as well, and I'm gonna put it there. So that is, I'm reading, right? In order to read any CSV file, you have to use panda, right? pd.read_NetCDF, and I'm gonna just create the index for the first column because I have that number, and I have to put it that way, / and let's see if I can do it quickly. Maybe I'm almost done. Okay, and then if you want to see the stations, right? Because I'm gonna print the stations, if I hit run, see, I have the list of this station. Now what I'm gonna do, I'm gonna loop through each of these stations, right? And then I'll create the file name, the output file name, and see, by this time it already generated the rainfall TS. See, inside that file, it's there. See, you can see that it's there. Okay, I don't need this one. I'm just downloading this. Okay, and I'm just deleting that one. Okay, and then what next? I have to loop through. So in order to loop through, we key and then value, and that stations dot iteration. Okay, value in station dot iteros, and that is the function. If you want to see what it is going to give you, if you print key, it will give you that 0, 1, 2, 3 number. If you want to print that stations, then you have to use a value, and this index should be 0. If you want to print the longitude, then the value and the index should be 1. And if you want to print that latitude, it should be index 2. Okay, so that's that. So we have access to our this one. And now if you want to even create the file output file name, okay, what will be the output file name? So I can generate this way. Formatted string, format, and then the value, okay? Because this value, and that should be 0 is the station ID. Then I'll have that .csv. I'm gonna export it as CSV, okay? And if I see, I'm gonna print the file name, and let's see, because I don't want to. Okay, I can even print that way as well. Run it. See, the first value, first one. This is the row I'm printing both, and it's gonna create the name of the output file .csv, right? And for this station, it is gonna create these file names. This is how we'll export and generate our time series, and we'll save that in that rainfall TS. Okay. So after looping through each of these things, and for our case, we have this number of files, right? And then I have to loop through this directory and each of this file. So how can I do that? Now I have to specify my input directory there as well. Now it's the time to specify my directory, and I can do it here. That is the output. Before specifying output directory, I usually do input directory as well. Okay. So that will be my input directory, because here I have my files, and there will be one problem because I'm saving that files inside this data file, right? So that's why what I have to do, because see, if I run this one, I'll have that folder there, right? This folder. And next time I'll run, it will even consider this one as a list of files. In order to exclude that difficulty, what I have to do, I have to provide another condition here. I'll only loop through those files that has that .nc4 extension, right? So how can I do that? It's pretty simple. It is not a problem. So when I'm done with my reading that CSV file, and I have the file name, everything ready for each of this file name, I have to loop through each of this NetCDF file to generate time series, right? So how can I do that? So here, now I have to change the directory to the input directory, or I can even see, this is how I do things there. I have similar code there for looping through each of this directory or folder. Just gonna use that os.listdir. This is how I do, okay? os.listdir. And I think I have this thing there as well. Wait a minute, if it is not there, I can generate extracting, okay? Wait a minute, maybe I have similar thing. It is not there. Okay. We are here, right? We are, okay, we are here. Now, since I already imported everything, I can write it, no problem. So for, I'm looping through each of these files from that directory, input directory, right? For file name in os.listdir, okay? os.listdir, that is the function. But what will be the listdir? That is the location, okay? It will list every files there. Let me just show you. And then if I have to use if condition, because there will be other files as well, I'm going to loop through only that .nc4 files. So if file name, okay, file name dot ends with, that is the command, ends with what? Ends with this .nc4, then it will only, then it'll do this thing or that thing. Okay, I'm going to print that file name, and I'm going to show you that. If it ends with nc4, then it will show this one. Okay, I'm going to show you only the file name. For each file name, means for each station, it will show you everything. Okay, that's what it should show right now. Running it, see, for each file, means the station ID, it will save as CSV file when I'll do that, and it is printing everything, every file. And for the next file name, it will even repeat the process. Okay, it is gonna repeat everything. See, within fraction of a second. We can't differentiate. Maybe it could be there anywhere. There it is, August 30. Okay, September. Okay, let me show you that. September. Yeah, when it's done with, see, when it's done with that September 30 and 23rd hour, it is gonna loop through another file. We'll do that. So we are okay so far. Okay. Now I have to read each of this NetCDF file, and I have to extract the variable, and I have to do some other processing. Then I'll be able to generate that one. So for each of this station, what I have to do, I have to create here the time. Okay, date time, empty list of date time. I'm specifying that because I'm gonna create that one, and then I'll even the data or the rainfall. Okay, rainfall. Empty list. I'll fill up this empty list, and then I'll generate data frame, and I'll save it as CSV file. That is our goal for today, right? So we have this file, and then I have to read in order to read any NetCDF file. So that is the criteria, because if you want to even run that, right? If you use NetCDF as dataset, that's what I did previously. So I don't need to even do that netcdf.netcdf. Or you can even do that, import NetCDF, and you can even follow this one as well. Okay, it doesn't matter. I'm gonna copy, since our file name is there, if it is ending with this name, so what will be the value of data object for this case? It will be file name and R. Okay, so this file name, if you just copy, because it will loop through each of this file, and it's gonna read, and I have the date time or data object, and I have access to every variable. Now what I'm gonna do here, I can put these variables, data dot variables and precipitation, this one. Okay, I'm gonna do it here. When I will read is file, then temp or temp precip or precip, okay, whatever it is, precip is equal to this APCP, and I'm gonna export all these values. Now I have every values, the precipitation values, right? I have that. Now what I have to do, if there is any negative value, there may be, then I have to take care of that values as well. So I have similar thing there. I can even show you from my previous processing. For the same case I did, because I tested that one, and I'm gonna just show you this pretty quickly. Okay, that doesn't matter. So just let me quickly show you. Okay, I'm just keeping it aside, and whenever it is necessary, I'll do it. Okay, so once you are done with that one, so you have to just make some treatment there if it is necessary. Otherwise, it is okay. If there is a negative value, because we don't want to use our negative value, right? So we have this variable precip, and then we are going to replace it. If the precip value is less than 0, means there won't be any negative precipitation, negative rainfall, right? That's why we are replacing these values with 0. Then what I'm going to do, I'm going to read our latitude and longitude, all this latitude and longitude, like the way we just import or extract this APCP data. So longitude will be this longitude, and all this longitude will be there as long, and latitude will be there as lat. And then what I have to do, as before, if you watch my previous videos, I just do this thing. I'm gonna make another array of square difference in between my station, the station I'm gonna give, and the station, right, on all this longitude here. I exported longitude and latitude, right? But before that, we have to export our lat point or long point, right? For our case, we have to be able to export that one. So how can I do that? I have these values, latitude and longitude for my station, and the lat point here, the lat where is my lat point? I have to use the lat point here, because for my case, I have the similar code. Just if you go up here, if I can use even similar logic from this one as well. The previous video I have, it is here, because I have the station name here, right? And then what I have to export, I have to export the latitude and longitude, this latitude and longitude. So if I use one index, it will be long point and lat point, because we are going to export this data for this longitude and that latitude. In order to do that, what I'm going to do, I'm going to just show you one more time the same thing I did, because the data I have, it is like this grid, right? Like this grid I have. We have, this is the longitude long, okay? This is the longitude along east and west, and I have the latitude as column this way. And basically what I'm going to do, because for example, I have this minus 80 and 26 there, somewhere there, close to here, okay? So I'm going to make the difference, because in the data set, I have this latitude, longitude, I have this latitude, longitude, this, and for all this point, I'm going to make the difference between this point and difference between this point, and this point, and every point, everywhere. I'm going to make this difference, okay? And this difference may be negative or positive. I'm going to make all this difference for every point, right? Every point I have for all this point from my data set and from my in between my point as well, location. And I'm going to make it a square so that it will be positive, right? If I square all of this, the value will be positive. And if I can consider the closest value from the data set as my point value, because otherwise there is no alternative way, because the data, right, it is either in this node or this node. So I have to find out the closest, I have to extract the closest value from the data set. So that's why I'll find the index of the minimum. This is the minimum distance, so it will represent this value. This point will represent this point. So I'm going to extract the data times this data for this point, and it will represent my point. So that is the thing I just did here, right? I made the difference and made it square, and then I'm going to find the index. Index means what is the number of this latitude, because if it starting from, right, if it is starting from this one, so 0, 1, 2, 3, the index of latitude will be 3, and what will be the index of the longitude? If it is 0, so 0 and 1, so this point will be 3, right? Latitude is 3 and longitude is 1. If I specify latitude is 3, longitude is 1, and for this first time step it has to be 1, means the index should be 0. If I pass 0, 3, 1, the time index is 0, the latitude index is 3, and longitude index is 1, then it will represent this point, and it will give you the value of the precipitation, okay? So that is the logic I'm going to use here, okay? So I think, yeah, you understood that one. So that is the difference I'm going to make. So long point in between all this latitude of that data and the lat point and all this latitude from that data, and I'm giving the name square difference latitude, a square different longitude. That is the point. It is not low level. Okay, and I'm gonna even export the longitude and latitude index of this latitude and longitude from this one. So what is the command for that one? It is argmin and argmax. If you want to even get the index of the minimum value from any array, that is the command argmin, right? So I'm gonna get the index of the minimum value of the square difference. I'm putting it there, minimum index latitude, minimum index longitude. It will give you that one. And we know the time is, right, this file has one time step. And if I want to even print, okay, the precipitation for this case, okay, let me just show you the print for my first point, print that precip. So what I have to pass 0 index for the time, and then the latitude, it will print the latitude, right, and comma that longitude. It will give you the precipitation, right? It will give you the precipitation. But here, okay, so no such file in the directory, because we are doing different thing there. Okay, not a problem, because we have another file here, a PCP. We have the file name. We are almost done, right? passive data, longitude, latitude, 12, line number 12 here, line number 12 data, NetCDF, oh, here, okay. NetCDF dot, oh, that is the reason I have to put everything all together, then it will work. I'm gonna copy this one and I'm gonna put it there. This is the time to make or compile all these things together, and I'm gonna copy, then it will run all together. Okay, so at the very beginning, here it is. Okay, so here I'm just modifying the kernel, I'm clearing everything, and let's start from the beginning. Okay, everything is done. So I'm importing this one. Here is my input directory, here is my output directory, and if this directory exists, it won't create, otherwise it will create. And then I'm reading the stations, I'm printing the stations, I'm listing date, time, rainfall, and looping through each of these stations and creating the CSV file name. And that is my long point, is my lat point. Okay, and then I'm looping through the directory. And for this case, what is the best way to do? That is the best way, chd, changing directory to input directory. That is the best way to do. os dot change directory. Okay, every time it will loop through this one, it will change the directory to this one. Then I don't need to put it this way, and then it should print. Okay, it should do the job for us if everything is okay. See, it's printing the value of precipitation and the file name as well. See, it's printing. It's pretty big because it will take a lot of time to print. We still have the value of precipitation 0.00000 for this case. Okay, maybe we'll have some values when the Harvey that will come, but I don't need that one. The code is working until then. Okay, so that's the point. So we are done with this one. Now what do we have to do? We have to add this value to my empty list there, the rainfall, right? This one. So I can put it this way as a variable, or I can directly add this. Okay, add this rainfall dot append, and I can put it this value. So it will create, okay, it will add this value of precipitation for that specific time period to this rainfall empty list. Then I have to even fill up the empty date time list. Okay, how can I do that? When it will read is file, because we know, right, the name of the file, we know it, so we have to split it. Let me just copy one file and follow the rule I did previously. So here it is. Is file name is this one. So file name, okay, when it will print the file name is .nc4. That is the file name we have. I'm just making it as comment. So what do we have to do? We have to split the file name, right? How can I do that? When I'm gonna split the file name, that is the comment. I think I already have it here, or I can even repeat that one, not a problem. So I think I have this type of thing there, the similar thing I did maybe. Let's check. Here it is. Okay, it is different one, but here. Okay, I'm gonna just split it. I'm gonna split the file name using, okay, first one I have to do this way. This is the general code because I have this code from my previous tutorial. I'm just doing the same thing. So here I'm just splitting the file name, splitting it because the format we know. The first is the AORC. I'm splitting it using os.path.split text. It will split in between, split into two. This will be the first part, and .nc4, that will be the second part as the file extension. And since I'll have this part, okay, this part, and I'm just splitting it using that underscore. So the first one is the AORC, APCP, and WGRFC. And this is the important part I need, right? This is the important part. So I'm giving is year, month, day, and hour, right? So this will give you year, month, day, and hour. If I just print it, it will give you this string value. So from this string, I have to create date time object. So here it is, right? I created that one, date time object. It is not a problem. I think I already have that here. So what do we have to do? We have to specify Okay, you have to wait a minute. Where? Okay, maybe it is there. Okay, wait a minute. So that is the format. If you pass that date time and strap time, you have to pass this way. It will give you that. Okay, that is the command we can use. It will give you the date time. I'm gonna show you right now. Here it is. Okay, I'm gonna print it. Print that date time because I imported that date time and strap time, and it's gonna print. Okay, because the string I'm gonna pass, the first one is the year. That's why it is the notation, and then month, and then day, and then hour. It's gonna print this date, time, hour, everything. Okay, so the file name, I don't need to print this file name. I don't need to print the value of the precipitation is time. I don't need to do that. It will only print the date time. Okay, this date time and file name as well. Okay, let me just check it. See, the first one, strap time. Date time has no attribute strap time because we have to import date time. We don't need this one. Okay, because from date time I'm importing date time dot time delta. See, it's working. So here it is. For this case, we have this file, right? Now reading the file, this file. Okay, now reading, when it will read the file, this command, it should be this file name so that you can understand that it is reading, is including that file. So for this file, it is excluding that extension. So it is creating this date time, 2017, 1st of August, right? August 1st and hour 10, right? That is the hour 10. So we are done with our date time. So what we have to do, we have to add this date time after creating that one, this object, to our empty date time. Okay, date time. So how can I do that? That is the thing here. It's just this dot append, and if I add this, it will populate this one. Okay, so we'll be okay. We may have to even kill our kernel because it is still running. We don't need to do that. Okay, so we are done with adding. We don't need to print every time. Okay, or we can even print. It is not a problem. We don't need to do that. It will populate our empty date time there, and at the same time I'm populating the rainfall. Okay, from here. Now it's time to save our CSV. Before doing that, we have to generate our data frame. How can I do that? We have to generate our data frame, and here is the code. I already have similar code, right? I'll have this data frame from this one. When I'll be done with is file name, so I have to go back from that for loop, and here I have to paste it, and that is the end of the loop for is station. Then it will start looping through is of this thing, and then date range and date time. Okay, I have this. I don't need anything. I don't need this one as well. This will be this. I don't need, because if we have your starting and ending time, we usually use that. But for this case, I'm creating this df pd.dataframe, and I have the list of date time index or date time object, and the column name is date time, and I'm just making this as my index. Okay, date time index. Then it's a time to add my rainfall data, and that will be the name of the header, right? Rainfall this way. Rainfall, and what will be the unit? We know it's millimeter, right? Rainfall, that is the millimeter. And since data is in basically hourly, so we can put it this way, millimeter per hour. That is the hourly precipitation. And I have to add the value of this rainfall. When it will be done, then it will add, and then it will print. Okay, it will print that df, and see the data frame there, df. But we don't need to print anything. Not okay. Now reading this one. Okay, don't need that. Okay, we can print the file what it is reading. All looking through this one, station name. Okay, we can try and then we'll save it. Okay, let's run it. See, it's looking through this one, and when it will be done for the first time, definitely it will show you the data frame if everything is okay. It's gonna show you the thing. Hopefully it's gonna show you that it's reading. See, it is reading up to August 18, right? Maybe it's out of memory. I don't know. It shouldn't be out of memory. Okay, let's see if it's continue running. Definitely it should. There is nothing I can see. There is no error. Wait. We don't need to restart our kernel. Dead kernel. What is showing? Dead kernel. Or we can run it in my Linux machine as well if there is anything wrong. I'm hoping. Maybe. Okay, wait a minute. These are the problem using your Windows machine. Sometimes it will show you this thing, that thing. Okay, not a problem. So I'm gonna finish off this when I'm done with creating the data frame, and I'm gonna save it. Right now it's the time. Okay, it's the time to save, and here it is. Okay, when I'll be done with that one, then I have to save it in my output directory. The following time series, the time series I'm talking about, that time series. I don't need that one, so it will be saved there. What will be the file name? This will be the file name, right? File name, and it will save everything there. Dir out, and then file name means it is the output file name, and it will save inside that rainfall if everything is okay. Maybe this kernel is dead. Let me just interrupt again, restart and clear if it works. Okay, now everything looks okay. Otherwise I'll run it in my Linux machine because it may be because of our memory issue. Sometimes this happens. It's reading. Even I don't need to. Okay, I don't need to show that. Okay, it's reading this file or that file. Appears to have died. Maybe. Okay. Okay. So here it is. It is maybe out of memory or something like that. I don't need to show anything then. I don't need to show anything. I'm just repeating the process. I'm done. Let's try now if it is gonna work. Everything looks okay so far. Okay, yeah, let's see. It will only show you the print when it will be done with the data frame. Okay, date range is not defined. Oh, that's what I was expecting. Here we have to change this name to date time. That's what. Okay, again clearing everything. These are the steps you need to know because I'm testing this script for the first time. That's why, because I know how to do that. And let's see if it's gonna work. Otherwise I'll copy the entire script and I'll put it there in my Linux machine. See, it's created the data frame. Can you see that? Yeah, for this data frame, and it's working for another one, the time and the date. And I'm going to show you this inside that directory. It should be there. See? Oh, the file name we need, it is different one. Okay, wait. The file name I put it should be the CSV file. I created the same name, so that's why it was station name. Okay, so here I should rename it because this file name and this file name, these are the same. That's why I have to create this as station name. Then it will be done. Station name, this should be station name, and I'm gonna kill it again. Okay, I'm gonna kill it and let's try. Definitely this time it's gonna give you everything. I'm gonna delete this entire directory, and okay, hopefully this time definitely it's gonna create. Then I'll show you the plot as well. After this one I'll show the plot because you need to show the plot as well, right? So it's gonna give you this one shortly. See, we have this time series, and definitely it's gonna give you CSV file this time. See, this is the CSV file you have, and this is the date and rainfall and millimeter, right? And I don't know the values. Maybe for the first time step or for this station it is 0, 0, and I'm gonna show the plot if there is any. So there is nothing. It's 0 for this station, 0 millimeter. Okay, for this station. Maybe for other station I'll have some data or not. Let's try. See, I have other stations as well. Still I have this 0 value. The value, still the precipitation I have for this station, there is nothing because it is outside of our precipitation region. Because I selected arbitrarily, I can even change the location, not here. Okay, maybe I have to change the location. Let me try for another station, because this is far away from the Harvey area. That's why there is nothing significant rainfall. It was in different place, not there, because I get some values there. You can see here, I can see small amount here. That's why, because I'm just arbitrarily selecting this location, but I can change the location from this to this one. Okay, find the another one, because it is Texas. It should be somewhere 98 there. It should be here. Maybe this. Okay, if I select 28 and 100, or even this location, okay, this location would be even perfect if I select this location, that location. Ultimately, this is the way we can even select. Since we can see we have the values of the precipitation there, right? So we can select 34, we can select 34, and okay, this area 34, or this area 30, and even we can select this 100, 30 and 100. Okay, 30 and 100. So instead of 80, so 80, it is far away from that one. 100, and this should be okay. This should be okay. 26. I'm just changing the values. 100 to show you only. 100, and this should be 100, and this should be like minus 95 and 27 arbitrarily. Okay, 97, 30. Okay, let's try with this one. If we have something, I saved it. Again, I can run the code and let's try. But before doing that, I'm gonna plot at the same time so that you can understand what I have here, right? If I plot it at the same time here using this code, because I have similar code there, then we can see here instead of changing all this together. Okay, so I'm gonna create a subplot, and this will be this thing, and I'm gonna plot the index, and this will be rainfall. Rainfall, and what will be the title? That will be rainfall. Okay, rainfall, and it will show you everything there. Okay, let's try if it's gonna print something or not. Definitely it should print something for this case. Since it is running, a station is not defined because I'm using that station instead of station name. It should be station name instead of station. Okay, it should be station name. This station name, because sometimes I use different code. So here I'm gonna run it again and see if it's gonna work. Definitely it should work if everything is okay. Otherwise, maybe I'll have other issues here. I don't think so that I have other issues, but PLT, okay, I have to even import that PLT because I didn't import that PLT. So I copied that one, and I have to even do this thing. Okay, PLT. In order to plot anything, you need to use matplotlib. Okay, you need to use matplotlib this time. These are the modification you need. And since I'm writing this code and testing in front of you, so this is how I just write code and test in Jupyter Notebook. And unit is not defined because we don't need that unit as well. I use this unit. I don't need that one. It will be millimeter, and I don't need that one. Okay, wait, instead of doing that, I can use that millimeter here. Okay, instead of that, I'll be using this millimeter, then it will put it there, and I'll have this thing, everything ready. These are the small details you need to even change, because if you copy this code, similar code from another location, then you have to change the variables, and maybe this time it's going to work. See, it's plotting. See, can you see that? Yeah, it's plotted. So now we have the precipitation value. See, the value is like 17.5 millimeter there, right? 10th of September, and you can see September 8 here, right? This location is a little bit away from, and is working for other station. You can see that, right? This is the precipitation, rainfall, and then it's going to increase. These are the values you have. 25 for this case, it is increasing, and yeah, these are the time series, and it is saving at the same time. So this is how we can download this AORC, right? This data that is very processed, already processed. You don't need to even convert it from grep to NetCDF. That is the benefit we have, and it's gonna finish off. See, it's increasing. See, when we have this location, August 22 to August 30, the value of the precipitation is 70 millimeter per hour. That means this is the Harvey. You can see that. You can check it. Harvey. This is the Harvey. See, Harvey is 70 millimeter per hour, and it is 70 millimeter per hour. So you can see huge amount of precipitation, right? Was dumping there over that area, coast of Louisiana and Texas, and you can see all of this at more than 70 even. See, this is where we have this event, storm event Harvey, and massive inundation was there. It flooded everywhere, right? And it cost a lot of money. So this is it. I think if you have any query, you can put it there. You can try by yourself. It's pretty simple. I'll give you the link of the download data in the description below, and you can download it for your time period, because it is extending from 1979 to the recent date, and that's the very important and useful data source, especially for precipitation. If you are a new user of rainfall, so you can process, right, your rainfall from NetCDF file, and then you can even convert your grep file if you want. But that's the very important part dealing with precipitation. You need to learn the data format, and that's it. Okay, I'm not gonna even elongate the length of the video. I'm gonna finish off here, and you can suggest me, or if you have any query, or you can even, if you need anything, you can even put it there. I'll try to make those tutorial as well, because other people, they're asking for something. I'm trying to even generate some kind of code based on their requirement. My intention is to help other students and learn new thing. This is the new thing, because sometimes I work on my research for different cases, but if someone asks to do this, I learn new thing. Because I like to learn new thing, and I like to take challenges. So that's it. Thank you very much for watching these videos, and thank you very much for supporting. Bye. Stay safe.